Welcome to our channel. Today, we're back with a brand new topic just for you. Before we start the podcast, please don't forget to subscribe to our channel and hit the like button. Enjoy the show.
Welcome to the deep dive. Today we're zeroing in on TypeScript. It's a technology that's really, shaken things up in the JavaScript world.
Yeah, definitely a game changer.
Right. Like think of JavaScript as this incredibly flexible, maybe sometimes a bit wild coding playground.
Mm-hmm.
And TypeScript sort of comes in as the safety helmet and the detailed blueprint.
Yeah.
It just gives you more confidence, especially for those really big, complex apps.
That's a great way to put it, that added layer of assurance.
So the big question we want to dig into today, something lots of developers have been thinking about, is what is TypeScript really?
Yeah.
And why has it gotten so incredibly popular over the last decade or so? Feels like it's just everywhere now.
It really is. And, there are solid reasons for that. Understanding its rise means looking at how JavaScript itself grew and the challenges that came with that growth.
Absolutely. Let's go back a bit. 2012, right?
Wait.
It's a TypeScript emerged from Microsoft. And the person behind it was Anders Heilsberg.
The C# guy.
Exactly. The creator of C#. And that connection alone kind of gives you a hint about where TypeScript was aiming, doesn't it?
It certainly does. I mean, Heilsberg obviously knew the power of strongly typed languages. He saw a chance to bring some of that discipline to JavaScript, which was getting used for much bigger things.
Right. Because back then, JavaScript was, king of the web, no question. But as apps got more complicated, you started seeing the cracks. A big one was that it's dynamically typed. Can you maybe unpack why that became such an issue?
Sure. Imagine building something complex, lots of moving parts. With dynamic typing, like in classic JavaScript, you don't really define what kind of part goes where until you actually run the machine.
Okay.
So you might accidentally say, put a string where you expected a number, and you wouldn't find out until, boom, runtime error.
The dreaded runtime error.
Exactly. And these errors in JavaScript could be anything from a small visual glitch to the whole app just crashing. Finding them in a big pile of code could be, a nightmare.
Totally. Those sudden explosions when the app is live, so frustrating and eats up so much time. And I guess as projects got bigger, just remembering what shape the data should be in became hard.
Precisely. Without clear types, figuring out what a function expects or what some variable holds in a huge code base. It was like trying to read a map with half the labels missing. Made teamwork harder, made maintaining the code long-term much tougher. Plus, the tools for JavaScript back then weren't quite as helpful as what you had in statically typed languages. Things like really good auto-completion or safe refactoring were less common.
Okay. So TypeScript steps in and basically suggests bringing some order, some predictability to this JavaScript world. And the core idea is pretty simple, right? Just JavaScript plus types.
That's the heart of it, yeah. It takes all the JavaScript you already know, the syntax, the flexibility, and just adds this optional layer of static typing.
And optional seems key there. You don't have to jump in feet first, rewrite everything.
Absolutely. That gradual path is a huge reason it caught on. But when you do add types, you're essentially telling the TypeScript compiler, hey, this variable should be a number, or this function needs an object with these specific properties.
Right, giving it more context.
Exactly. And that lets the compiler check your work before you run the code. So instead of hitting that runtime error later, you get feedback right in your editor during development, like a spell checker, but for type mistakes.
Wow, okay. That sounds like a massive improvement for stability.
Yeah.
Catching those silly mistakes much, much earlier.
It is. It shifts bug detection from, potentially expensive runtime surprises to the much easier development phase.
Now, TypeScript isn't just about adding types, is it? It also keeps up with JavaScript itself.
Totally. It has great support for all the modern JavaScript features, ES6, ES7, all the good stuff. Classes, arrow functions, async await, everything developers like using now. And the clever part is, TypeScript can take all that modern code and compile it down to older JavaScript versions. So your cool new code still runs in older browsers or environments.
So you get the best of both, right? Modern, run anywhere.
Pretty much. And you mentioned it pulls ideas from languages like C# and Java. What kind of features are we talking about?
Well, things like interfaces. These let you define a shape or a contract for your objects. Like any user object must have a name string and an ID number.
Okay, like a blueprint for data. Exactly. ensures consistency, stops errors from typos or missing properties. Then you have enums named constants, basically. Makes code easier to read than just using raw numbers or strings everywhere.
Right.
And generics. Those let you write reusable code components that can work with different types but still stay type safe. Really powerful tools for building bigger, more robust systems.
Okay. That gives us a solid handle on the what. Let's really dive into the why now.
Yeah.
What are the killer advantages that made so many people switch?
Well, number one has to be catching bugs early. That impact of static typing, finding errors before runtime, it's huge. It's like finding a fault on the factory floor instead of after the product shipped. Saves so much debugging time, leads to way more stable apps.
Yeah, fewer of those, but it worked on my machine.
Yeah.
Moments that end in disaster.
Exactly. And that quick feedback loop just makes you more productive as a developer.
You also mentioned better tooling. How does TypeScript actually improve the experience inside, say, VS Code?
Oh, this is massive. Because the types are explicit, your editor understands your code way better. So VS Code, which, is built with TypeScript, can give you amazing autocompletion. It knows what methods are available on an object.
Smart suggestions.
Super smart. And it flags errors as you type, like putting a red squiggle under a potential type mistake. Plus, refactoring tools become much safer. You can rename a variable across dozens of files and trust that the types will ensure it's done correctly.
It's like having a really smart assistant looking over your shoulder.
Kind of, yeah. A co-pilot that catches silly mistakes. For big teams, just cutting out whole classes of type bugs before code even runs, that's a major time saver.
That makes a lot of sense. So it helps the developer directly. What about the code itself? Does using types make it easier to understand later on, or for someone else to pick up?
Absolutely. Those type annotations, they act like built-in documentation that's always up to date because the compiler checks it.
Ah, interesting. Living documentation.
Yeah. You look at a function, you immediately see what kind of data it needs and what it gives back. Makes it so much easier to understand the code's purpose, especially if you come back to it months later or if someone new joins the team. Big boost for readability and long-term maintenance.
It's like comments that are guaranteed to be accurate. Okay, we've touched on individual benefits, but how does it scale? What about those huge projects with dozens of developers?
That's really where TypeScript comes into its own. The type system acts like a shared language, a contract between different parts of the application and different team members.
A common ground.
Exactly. It cuts down massively on integration problems where one part sends data the other part wasn't expecting. That shared understanding and enforced consistency, it's invaluable for managing complexity in big apps and making sure everyone's on the same page.
So it helps teams work together more smoothly.
Yeah.
You also brought up using modern JavaScript features. How does TypeScript handle making sure that new stuff works everywhere?
Right. So the compiler is key here. You write your code using the latest, nicest JavaScript features, async await, optional chaining, whatever. Then, when you build, the TypeScript compiler translates that into equivalent, maybe slightly clunkier JavaScript that even older browsers can understand.
Ah, okay.
So you get the developer experience benefits of modern JS without sacrificing compatibility.
And one last thing on advantages. What about existing projects? If a team has a huge JavaScript code base, is switching to TypeScript a nightmare?
That's another smart thing about its design, because any valid JavaScript is also valid TypeScript to start with.
Oh.
You can migrate gradually.
Oh, right. Step by step.
Yeah. Rename your JS files to TyTS, maybe start adding types to new code, or tackle one critical module at a time. You don't have to do a massive rewrite all at once. That smooth interoperability makes adopting it much less daunting.
Okay, the case for TypeScript seems pretty strong. No wonder it's taken off. Where are we actually seeing it used most prominently today, like in the wild?
Oh, it's pretty much everywhere in modern web development now. Front-end frameworks, huge adoption. React, Angular, Vue, Svelte, they all have first-class TypeScript support. Many, many projects using these frameworks choose TypeScript for that extra robustness.
So front end is a major area. What about the back end Node.js stuff?
Definitely growing fast there, too. Building servers, APIs, the benefits of static typing for making those reliable and easier to maintain are just as important on the back end. Helps teams build much more solid server-side systems.
Interesting. Anywhere else beyond the typical web stack?
Yeah, cross-platform apps, too. Frameworks like Electron for desktop apps and React Native for mobile, you see TypeScript used there more and more. Especially in bigger projects where managing code across different platforms gets tricky. Catching errors early is even more valuable then.
You mentioned some famous examples earlier. Can you remind us of a couple of big projects built with it?
Sure. Angular, the whole framework from Google. written entirely in TypeScript. And, as we said, maybe the most meta example is VS Code itself. The editor so many people use to write TypeScript is built with TypeScript.
Oh, okay. That's quite the endorsement.
It really shows it can handle complex, real-world applications effectively.
Okay, so lots of positives, but let's be balanced. No tech is perfect. What are the potential downsides or challenges people should know about?
Yeah, good point. There are definitely things to consider. First is probably the learning curve. If you've only ever known dynamic JavaScript, getting your head around static types, interfaces, generics, it takes some time and effort. It's a different way of thinking.
So initial investment to learn the concepts.
Exactly. Then there's the build step. Plain JavaScript just runs. TypeScript needs to be compiled into JavaScript first.
Right, that extra step.
It adds a compilation phase to your workflow. Not usually a huge deal with modern tools, but it's an extra piece you need to manage in your development setup.
Makes sense. And the type system itself, can it sometimes feel, I don't know, restrictive or just complicated?
It can, yeah. While it's mostly helpful, sometimes getting the types just right, especially for complex scenarios, or when working with third-party JavaScript libraries that maybe don't have perfect type definitions yet, can be tricky. Some advanced type features require a deeper understanding.
Okay. And you mentioned earlier that the types mostly disappear after compilation. What's the impact of that?
Right, type erasure. The types are mainly for the compiler to check things during development. They're stripped out when generating the final JavaScript. This keeps the output small and fast, no runtime type checking overhead. But it means you can't really inspect an object's TypeScript type while the program is running. Usually not a problem for typical app development, but it's a difference from some other typed languages and something to be aware of.
Got it. So some trade-offs, but it sounds like for many, especially on bigger projects, the benefits really win out.
Yeah.
Looking forward then, what's the future hold for TypeScript?
Yeah.
Is this momentum going to continue?
Oh, absolutely. Everything points towards continued growth. Adoption is still climbing rapidly. More and more companies, big and small, are making it their standard for JavaScript development. It's really moving from nice to have to expected in many modern stacks.
And the support behind it seems strong.
Very strong. Microsoft is obviously heavily invested. Google uses it extensively. And there's a huge active open source community contributing. It's constantly evolving, getting new features, better tooling. It's a very healthy ecosystem.
So for people listening, maybe wondering if they should jump in, who really benefits most from learning TypeScript?
Well, pretty much any JavaScript developer who wants to build more reliable, easier to maintain apps. That's the main thing.
Right.
It's especially valuable for teams working on large front-end or back-end systems where complexity and collaboration are big factors. Anyone using modern frameworks like Angular, React, Vue, you'll find TypeScript skills are increasingly in demand, almost expected sometimes.
Right.
And, anyone who just wants better tooling, easier debugging, safer refactoring, TypeScript really delivers on that front. It makes you a more efficient developer.
So it covers quite a broad range of developers then.
Definitely. It's really an investment in writing better code and just being more effective in the modern JavaScript world.
Okay, let's try and wrap this up. We've gone pretty deep into TypeScript today, where it came from, what it does, the pros, the cons.
Hopefully giving a clear picture of why it's become such a force in the JavaScript world.
Yeah, I think it's clear it takes JavaScript's great flexibility and adds this crucial layer of safety, structure, and, well, future-proofing.
Yeah.
It's not just another tool, is it? Like you said, it feels more like a fundamental shift towards writing better, more maintainable code that scales.
Exactly. It really empowers you to build complex stuff with more confidence, fewer nasty surprises.
This has been really insightful. Maybe next time we could look at something totally different like Rust and memory safety or Python's role in data science. Lots to explore out there.
Sounds good.
But for now, for everyone listening, thanks for joining us. Keep coding smart and keep those types checked.